Hey guys, let's solve this statistical estimation problem. So we are given this set, this support of a random variable, of a set of random variables. So S theta is the set in the R2 where x and y are both greater than 0 and x plus y is less than or equal to theta. And the random variables x1, y1, this bivariate random variable, x1, y1, dot, 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 x and y, and this n bivariate random variables is a uniform distribution over this set, S theta. So we are asked to find the likelihood of theta, the likelihood of theta, and the theta hat, the MLE of theta. So let's try to do that step by step. So the first step is to understand, and since it's uniform over S theta, we need to know its area. So we need to plot this S theta, first step. So let's plot this S theta properly. So if you observe, this will be, this is x, this is y, and x is greater than 0, y is greater than 0, and x plus y is less than or equal to theta. So this will be less than or equal to this line, theta, and the area is this. So this xi comma yi, this xi comma yi is nothing but an uniform distribution over S theta. So it will have the following density. So f of xi comma yi, x comma y will be equal to, so it will be equal to, the density will be equal to 1 by the area. So what is the area of it? This is theta, this is theta, so the area of it is theta squared by 2. So this will be 1 by the area, 1 by a, which is nothing but 2 by theta square. So let me rub it off. 2 by theta square if x comma y belongs to S theta and 0 otherwise. So this is the density. The first step is the density because you have to find the likelihood. So now let's find the likelihood. Okay, let's find the likelihood now. So the likelihood L theta is nothing but the product, since these are IID, so I forgot it, it's IID. This is IID product of this n random variables, the product of the density of this n random variables, f of xi comma yi, x comma theta. So you can say f theta. So we should say xi comma yi, and here we should make it general, x and y. This is the likelihood is the product of this, and we will get that this is equal to the product of, so let's, since it's it's together, it's a partition function, part by part function, we have to write it in that way. So it's product of 1 to n 2 by theta if all the xi comma yi, if the xi yi belong to S theta, if all the xi yi belongs to the S theta, all. So this is a bit non-mathematical in nature. This is like a bit of qualitative way of saying this. So what should we do? Should we use something called a beautiful idea of indicator functions? So we do that it's indicator that all xi yi belongs to S theta, and it's 0 otherwise. If all of them if there exists one which lies outside S of theta, then the entire product goes to 0. Okay, this is very important, guys. So once we do this, we have to now. So we have less space over here. Let's make it more clean. So we'll rub this off and we'll rewrite this. So likelihood L theta is this product. So this product is this is outside, it's product of all indicator functions, and we will take this constant outside. So it will be 2 to the power n by theta to the power 2n times. It's a product of indicator random variables. So you can write that can be written as product of indicator of A times indicator of B. You can write it as indicator of A intersection B, because that's the only when it will be 1. So this is a small exercise for you. Indicator of A times indicator of B is indicator of A intersection B. So we'll use that to get that all x1, y1, all of them lies in S of theta. Okay, so this is a better way to write it. Okay, if you write an indicator, it automatically means that it will be 0 otherwise. So we are trying to achieve a compact mathematical representation of it. Okay, and from that compact mathematical representation, the MLE will arise. So you can observe that here this is equal to, so we will rewrite this now, this section now. So it's 2 to the power n theta 2n times. So what does this mean? So let's rewrite this. It means that indicator, each of the xi's, all the xi's, so we will rewrite this expression here. All the xi's are greater than 0, all the yi's are greater than 0, and all the xi plus yi is less than equal to theta, all of them, right? And we will get that it's theta to the power 2n times, so all of them greater than 0, so we want a compact representation of that. So we can see that it's indicated that the minimum, if I say that if x1, x2, xn are this, random variables, are the samples, if I say all of them are greater than 0, it's equivalent to saying that the minimum is greater than 0. It's equivalent. If all of them are greater than 0, implies the minimum is greater than 0. If the minimum is greater than 0, it implies all of them are greater than 0. So we will compactly write this x of 1, that is the first order statistic, is greater than 0. The y of 1, the first order statistic of y is greater than 0. Now what about this? Xi plus yi is less than or equal to theta. So we can consider another random variable, xi plus yi, and that is, let's consider zi as xi plus yi, and you want all of the zi's to be less than or equal to theta, which is equivalent to saying that, again, if you want all of a certain random variable or certain quantities to be less than or equal to certain number, let's say theta, it's equivalent to saying that the maximum of all those random variables is less than or equal to theta, right? And similarly, it's equivalent to saying that if maximum of all the random variables are less than or equal to theta, it implies that all of the random variables are less than or equal to theta. So we'll use that. So it's equivalent to saying that the max, the max of this is less than or equal to theta. This is a new random variable. The max of this is less than equal to theta. So this gives a very compact representation. Now we will make, so this is a function of theta, remember. So we will make this separately into theta part and non-theta part. For example, this indicator, this is not dependent on theta, so we can take it out. Again, we will use that product of the indicator random variable property, which is not here, but imagine that. So we will have 2 to the power n divided by theta to the power 2n times this indicator, which is dependent, this is the part dependent on theta, indicator that the max, so let's write z here, so z of n is the max of that, so we are using z, indicator z of n less than equal to theta times the rest of the stuff. Let's call it c. It's a constant, it's not dependent on theta, it's a constant. So we'll rub it off and we will rewrite this entire expression to save space. So it's indicator, some constant, positive constant, non-negative constant, times indicator z of n is less than equal to theta, the maximum, and this is our likelihood, where c is equal to indicator x1, y1, both are greater than 0. Okay, and zi is equal to xi plus yi, and zn is the maximum order statistic. Of zi's. So the first one is done. Now let's find the theta at ML. It's very easy now. We have found the function, the likelihood. We want to see where the likelihood for which theta, the likelihood is the maximum. That's where the likelihood is maximized, and the theta where its likelihood is maximized is called MLE, the maximum likelihood estimation. So let's plot this is theta, and this is L of theta. So we will get, let's plot this. So some function, let's not think about it, let's assume it's C, but let's plot the structure of it, the graph of the plausible graph of it. So observe that when theta is greater than or equal to this specific quantity, okay, when theta is greater than or equal to this specific quantity, this is this value, else it is 0 because it's indicator random variable. So therefore this specific quantity is very important marker, that is z of n, right? So after this behaves like this. So here, so after this it behaves like c into 2 to the power n by 3 to the power 2n, and before this it's 0. It's open, yeah, because it's theta greater than or equal to, so it's open here. So observe that, how does this function look like? It's a decreasing function. It's like some constant times some k by theta to the power some m. So it's a decreasing function in theta. It's very easy to prove it's a decreasing function. So it's easy to prove. So you can just do del theta to the power minus m by del theta, and you will get this is less than 0. So this is decreasing. Try it out. It's small exercise if you are not aware of this. So this will be decreasing in nature, and it will start with this exact value at Zn. So here what theta is equal to Zn will put, if you put theta is equal to Zn, you will get this value, and it's decreasing from here. So therefore, where theta is maximized is Zn. So theta at MLE is z of n, which is max of all xi plus yi's. So this is all about it. I hope you enjoyed this discussion. If you enjoyed the discussion, do share your support and it will motivate me to create more such videos. Bye bye.